All right, so you found on Canvas the announcements link on the home page, if you haven't done so already, where we have our oops, week one. Make sure that you download the instructions and the Excel data file. Those are going to be the two things we're going to use today. So that's who I have here. Now, also on here is Wyatt. Wyatt is our TA for the class, and so he will be, so in lab, normally he'll be along with me going around the room, helping you figure out how to set things up, troubleshooting, those kinds of things. All right, so the first thing we are going to do is we are going to, of course, look at the syllabus. So let me share that. Chemistry 113. You should all be enrolled in Chemistry 112 or have taken that course before. At the beginning, not a lot of overlap, but once we get past the first couple of weeks, then there's going to be a lot of overlap with what's going on in the 112 class. And so having the content from the 112 class will be important. Required materials. So unlike last semester, where you just turned in data sheets, this time you're going to have a notebook. Now, if you don't have it right now, that's not that's not a problem. We're mostly going to be using it later in the semester. But next week I'm going to have you start writing in it just so you can kind of get used to what it is that I want you to keep in there. And then in the second half of the semester, you'll be graded on it. So if you think of those composition books or a spiral notebook, that would be a good thing. But it should be dedicated, means the only thing that's in there is for this lab. So if I decide to collect the notebooks, you can turn it in and it doesn't affect your ability to do anything in other classes because there's nothing in there except for lab stuff. So make sure you have that. I do have a handful of extra ones in my office. So if you can't get to the store or whatever, next week in lab, I'll have out the extra ones if you want to grab one. You do want to have your own scientific calculator when we do quizzes and tests online. I'm sorry, in class, you're not going to be able to use your cell phone, so you're going to need to have your own. You don't need a real expensive one, so the ones that we have in our class set in the classroom are sufficient. So if you have one like that, those are usually $10 to $15. So you don't need a fancy $100 calculator. Tablets are very useful if you are doing graphical analysis, which are going to be after spring break. You can use a cell phone on those, but it makes it really hard to see what's going on. We have tablets that you can use. So I don't want you to go out and buy a tablet. But if you have a tablet, if you have an iPad or something similar, that can be something that can be useful in the lab. Um, if you don't have it, don't worry about it. We have things that you can borrow. All right. Our learning outcomes, we're trying to get you more proficient in how to work in a lab. We're trying to help you reinforce the theoretical basis of the concepts that we're working on, and we're trying to help you work with some of the tools that help you represent data, especially Excel with graphs. So those are things that are important, and of course, always safety and communication. So those are the outcomes we're looking for. Um, Remember that when you are in a class, you're kind of expected to spend some time outside of class preparing for that class. So make sure that you are remembering that it's not just show up at 8 a.m. on Tuesday and then not think about it after 11 a.m. on Tuesday. You're going to have reading ahead of time. A lot of your pre-lab quizzes will be on Canvas, so kind of keep those things in mind. All right, so this is how the grading scale works, not unusual. I would expect that if you show up to every lab and put in an effort, your minimum grade would be a C. But if you're skipping labs, if you are not putting in effort, then your grade could fall below that. So, make sure that you're present both physically and mentally. So you're going to have 20% is professionalism. That means having your materials ready to go ahead of time, your pre-lab quizzes, um, making sure that you are handling things carefully in the lab and that you're not goofing around, those kinds of things. Also, we want to have making sure that you're cleaning up after yourself, wearing proper goggles and when appropriate gloves and lab coats and things like that. So down here, you'll see the lists of professional behavior, and then this is unprofessional behavior that you might get docked for over there. So I will let you take a look at that on your own time. I'm not going to read through that. So 60% is going to be lab reports and notebooks, and lab notebooks. So sometimes you're just going to turn in whatever data information when we work on Spartan, which is a computer program, or today you'll have data sheets you'll turn in. But towards the end of the semester, we'll be building towards writing a formal lab report. So we'll have combinations in there. There are two tests, a midterm, and the second test is your final exam, but it is not cumulative. It is only for the stuff from spring break. So the midterm is going to be up until the midterm, which is actually, I think, a week after spring break. So, so you have everything up to spring break, and then everything after spring break on the final. So that's kind of how everything works there. So if you have questions on everything we've covered so far, you can unmute yourself and shout them out, or you can put them in the chat. That works as well. Okay, so course policies. Lab is something you absolutely have to be here. You're getting your minimum of a C, depends on your completing all of those labs. If you are um, missing a lab, in addition to getting a 0 on the lab, you will also be docked 4 percentage points off of your otherwise grade. So make sure that you are making up any lab that you miss. Make sure that you are there when you can be there regularly, but if you absolutely have to miss, make sure you make it up. And if you miss 3 labs, then you just get an F. So make sure that you are in lab. Generally, the normal kinds of things would be excused. Lots of times we have sports things or scholastic events. We would expect those to be excused. I don't want your germs any more than you do. So if you're sick, it might be better to do it at a different time. And the reason that we can do this is because we have the labs both on Tuesday and on Thursday. So the expectation is if for some reason you're missing Tuesday's lab, that you're going to come in on Thursday and do the lab at that time. Or if you can do it in the afternoon on Tuesday, do it at that time as well. If that is not possible, it is your responsibility to make sure that you have arranged with me a time to make up that lab. It is not my responsibility to hunt you down and arrange it with you. You make those arrangements. So make sure you are getting your labs done, and if you miss a lab, make sure you are there to make it up. So that's kind of what this paragraph says here, and do it in the next class or make arrangements. You're responsible for that. Artificial intelligence. So when we get to stuff that you're turning in more formally, I know the temptation is to be looking at stuff online. You are not to be using AI. This is a class that's supposed to train you to be thinking and writing and using your own voice to say things. So AI should not be used for anything in this class unless I explicitly tell you it's okay. And I can't imagine at this point anything that I would say it's okay for. So ChatGPT, Google, whatever it's called, none of those things are appropriate for this class. Now, of course, when you are in class, you're the one looking at the burette, you're the one writing things down in your notebook. So really, there's not much use for AI in the lab anyway, but make sure that you are not doing that. Now, something I want to point out to people is that if you have already an honor code violation and you get a second violation, the minimum penalty for a second honor code violation is an F in the course. So if you go and use AI, and this is something that you're held accountable for in this class, but you already had an honor code violation, no matter what I say about, well, I'll just give you a 0 on the assignment or whatever that case may be, you end up with an F in the course. So make sure that you are not violating the honor code. All right, academic accommodations, please let me know if you need some accommodations, especially extended time on quizzes, because if I have a time limit on the quiz on Canvas, I'm going to have to manually put in an extension on your time. So make sure you get me that letter of accommodation. Also be aware that I cannot give you an accommodation just on your word that you have a letter. I have to have that letter in hand. If I give you an accommodation without a letter, I need to give everybody that accommodation, and it's not realistic for me to give time and a half to everybody on everything. So make sure you give me that letter of accommodation. Make sure that you are aware that the college is not supportive of harassment or of any kind, but in particular, anything, let's see, reports of harassment, disclosed pregnancy, discrimination, and retaliation with any of those kinds of things. Um, you can report that to the Title IX coordinator. So if you go over to Highball Hall, where all of the student stuff is, if you have a problem with any of your classes, if you're being harassed or discriminated against, or if you need to let them know that you're pregnant and you're worried about how that might be, how lab might affect that, you can disclose that to them. They keep everything very private, and they can help you out with any of that. Here's our lab schedule with the lists of the labs that we'll have. You can see here is spring break, and our first test is actually a little bit after spring break. So not right after, so you're not going to have to spend your days on the beach studying for your midterm, but pretty close after. And then this is going to cover your initial experiments. And then your final exam will be during this time. And the final exam times for this class is May 14th, but I am happy to have you take your final exam with the afternoon class if you want to get out of here early. And that is May 11th. I think that's the Monday. So when we get closer to that time, I'll be asking if anybody wants to switch when they're taking their time. All right, so this is the end of the syllabus. So again, I will pause and say, does anybody have any questions? Hopefully you've had a chance to do these items here. So Dr. Hughes put this together so that each week will be pretty similar, and it'll tell you what to read, videos to watch, and if there is a pre-lab quiz to do that. So we have our background information here. This is the information that is really good to have in your notebook so that when you are writing or making a graph, next week we'll be doing a graph, or if you have a quiz or a test that I allow you to use your notebook on, you can go and refer to this stuff. So we've got a lot of good information in here. Now, of course, you can't have the videos, which are on the next screen. So you would want to take notes on those things. Now, most of this stuff is written for graphs in general, but not keeping in mind how scientists use graph, and chemists are generally going to stick with the scatter graphs rather than bar graphs and line graphs and those kinds of things. So I'm going to talk a little bit more about scatter graphs, but these are some good things, especially how to spot a misleading graph. If you have to do one of the things that are in here, if you have to truncate a graph, it's very good to let people know you are going to do that. Be very clear about that. So if you haven't had a chance to do that, you are going to want to look through all of those things because you'll see here, take pre-lab quiz here. Now, normally your pre-lab quiz would be due the day before lab, but since we hadn't met yet, it's going to be due this evening. So that's on your assignments. If we look at this through student view, and we see our lists of assignments. We've got reading and watching and downloading, and then we have pre-lab quizzes not showing up there. I guess we have too much stuff. We already did this. We did that. We did that. Okay. I'll have to make sure that that shows up for you, but you do need to do this pre-lab quiz. All right, so again, any announcements on, or not any announcements, sorry, any questions so far on what we've gone through? All right. At the top here, I forgot to mention this. This is all of the information that would be on the syllabus, but in more detail. So I'm not going to go through this line by line, but if you have questions, sometimes this information can be helpful. In particular, you might want to look at this learner support services. So this tells you about the help desk that can help you with any technological things, accommodations, who to contact for those kinds of things, the wellness center. So all of the things that you might need help with are on this particular page. Normally, since that's just an as needed reference, I just click this little triangle and minimize it. But that information is there for you. All right, so we're going to switch gears here. And I told you I was going to talk to you a little bit more about, oops, I do have to share that. Otherwise, you won't be able to see it. Share this. Yes. This PowerPoint is on Canvas. If if you look in the files, you'll be able to see it there. Yes, continue to share. Okay. But you can just watch what's on the screen for right now. So this has things for all kinds of graphs, but I'm just going to focus on the scatter graphs. So remember, whenever you have a graph in a lab report or that you turn in, I'm going to be looking for either a caption or a title, usually a title, telling me what the graph is about. It shouldn't be just one word. It should be more descriptive to tell me what it is that I'm looking at. If you have scatter graphs, which is most of what we're going to use, you should label the axes, and that should be both what it is you're measuring, like temperature or volume, and the units that you're using, like milliliters, or are you doing Kelvin? Are you doing degrees Celsius? Those kinds of things. And then if you happen to have a bar graph or a pie graph, you should label the categories. For us, that's not really going to be an issue. And then, as I said, make sure you have units. All right, so scatter graphs are used by scientists because generally we're kind of going in reverse of how somebody who's reading a graph would be looking at it. We're not trying to say, this is the trend. We're trying to say, this is the data. What can we learn from it? So on a scatter graph, you would plot your data points and then you'd say, that looks like there's a pattern, and then try to discern the pattern. So when are you going to use it? Scatter graphs would have two numerical kinds of data. So we're not going to have any categories, and they should be continuous data. So if you think about like the days of the month are numerical, but January 1st versus January 2nd, there really isn't a January 1st and a half. And so if I'm using something that has numbers, but I can't have any possible number in between, then that would really be more categories than continuous data. So if I think about volume, I could have 10 milliliters or 11 milliliters, but I could also have 10.5 or 10.45 or 10.4345. Every possible rational number between 10 and 11 is possible. That's what we mean by continuous data. So things like time, volume, concentration, absorbance is what we're going to be looking at next week in lab. So as you look over the materials for next week, you'll understand that a little bit better. So those are the kinds of things we would put on a scatter graph. They have numbers and there's all possible values in between. Now, when we have that data and we say we think there's going to be a pattern, we're going to try and add a trend line. So the trend line is trying to show us the mathematical relationship between the dots. It is not connect the dots. We're not going to do a line between these two, a line between those two, line between those two. So that's what in the videos they called line graphs. And I'm not a huge fan of line graphs because it makes it seem like it's continuous when it's not. So we're not going to connect the dots. We're going to add a trend line. Hello, Derry. We are talking about different kinds of graphs here. So we're not going to connect the dots. We're going to add a trend line. And then you'll see in a minute this R squared value. That is going to show us how good that line represents the data. So if it is a really good fit, then we're going to have something very close to 1. So think of that as like 100% fit. And if it is a bad fit, then it's going to be a lower number. So if I take this data and I add this line, so this is a linear fit, it kind of shows that upward trend. But you'll notice here, and this kind of happens to us sometimes in our data, even though it's kind of going through the middle of it, the middle data points are below the line and the end data points are above the line. And when that happens, that usually is telling us this is more of a curve than a straight line. So this has a fit of 0.96. That's pretty good. We'd like to see in chemistry, we like to see things that are closer to 0.98, 0.99, but that's okay. But if I change how I'm trying to fit that data, if instead of trying to do a straight line, I do a curve, so this is a polynomial that represents this curve, now you see that R squared value is 1. Okay, so when we're trying to see what equation best fits the data, the way that we can tell whether one is a better fit than the other is by looking at this R squared value. All right. So when we add trend lines, and we'll talk about how to do that in a minute, the trend line is trying to approximate what best fits the data. Usually in lab, we are going to do a linear fit. And if you remember from algebra, the linear equation is y equals mx plus b. So if I look at this equation here, and it's pretty small, oops, let me go back. I have y equals and then a number. So that number next to the x is m. Remind yourself what m is. M is the slope. So slope is how steep this line is. You might remember the phrase rise over run. So if I rise a lot, but I only go over a little, then I have a steep line. So a big number means I have a very steep line. And a small number means I have a very gradual rise here. So this is 0.89. 0.1 would be a 45-degree angle. So this is a little less than a 45-degree angle. And then B is our intercept, which means where does this line hit the y-axis? Well, since it doesn't show it, that means it's plus 0. So it's going through the origin here, 0, 0. This line hits the y-axis at 0. Okay, so that information can both be used to try and figure out what's other points might be. So I might say, well, what is the volume going to be at 300? And then I could use that equation to figure that out. but then that plus B is sometimes useful for telling us information as well. So it's not relevant in this case, but sometimes it's very useful. All right, so this trend line is linear, but there are other fits. We could have exponential, logarithmic, polynomial, so there's lots of different kinds. And the trend line is what connects what's going on with the data, the points, to the equation itself. And then remember, anything that is linear is directly proportional. So that means as one goes up, the other goes up, and they go up at the same rate. So what are some other kinds of graphs? We could have inversely proportional. So remember, pressure and volume of a gas are inversely proportional. So this means that as the pressure increases, the volume is going to go down. And as the volume increases, the pressure goes down. There we go. Okay. So notice that for the inversely proportional, it's curved. It's still proportional, but it's not a straight line anymore. Okay, so when we see this downward slope, we might want to check out to see if it's inversely proportional. Now, how does that look in the equation? In the equation, x says to the -1. So to the -1 is the same thing as 1 over x, that fraction, 1 divided by x. Okay, so when y is equal to 1 divided by x, or x to the -1 times the slope, that's an inverse proportionality. Then we have exponential, and I left out the line here to remind you that what we're really interested in is the data, and the line is just showing us the best fit. But this is a curve upwards. So it's different from inverse. Inverse was curving downwards. Our exponential is curving upwards. Okay. Now we could have curves going in either direction that the equations can get complicated, and that's why you look at the r squared to tell you what's the best fit. But this is what an exponential fit looks like. And in the equation, notice I see the letter E here. Okay, so that E is related to that natural log on your calculator. We're going to see more of that this semester, particularly when we get to kinetics as well. And notice X is up here in the exponent of E. So E is a number, and then we raise that number to this power times whatever X is, and we get this curve. So exponential growth, sometimes populations grow that way. We hope that our bank accounts, when they have interest in them, that they grow that way. They don't usually, but we would hope they would. Those are exponential graphs. The rest of this is just other kinds of graphs that we won't really use. So you can look through them if you want to for your pre-lab quiz. You can have that open while you're looking at your pre-lab quiz, but I'm not going to go through that right now. So what we're going to do now is we are going to look at the assignment on graphing. So you are going to want to pull up your file that you downloaded that is an Excel file. So it has some data sitting here. You want to pull that up on your computer. Now, if you are somebody who has a Mac and you haven't figured out how to pull up Excel, open it with Numbers. So Numbers is the program that is most similar to Excel. If you are such a person that has to use Numbers, first of all, that's going to work okay for today, but in the future, we're going to have to use Excel. So if you need help trying to figure out how to use Excel, let me know. But if you are using Numbers, if you go to Files, you should be able to find in the Experiment 1 Graphing folder something that says Graphing with Numbers. So this file here will show you there's a little bit of difference in the buttons you click on and those kinds of things. That'll help you find what you're supposed to do in Numbers as opposed to Excel. They're very, very similar, so you might be able to figure it out anyway. But if you're having trouble, pull that file up if you're using Numbers. All right. The other thing that you are going to have out, hopefully you printed it out, but if you didn't pull it up on your computer, is the worksheet that has the instructions on it. And let me find that. That. Okay, so this is the paper you should have out, and you're going to follow this to do the instructions on the Excel sheet. Okay, so in silico is Dr. Hughes's way of saying on the computer. So when you do something in a test tube, you say in vitro, and when you do it in a living organism, you say in vivo. So those are sciencey terms for where you're doing something. So she's saying in silico because we're doing it on the computer. She's just being cute. All right. So you want to be able to use data that is in Excel and then do calculations on the whole set of data at once rather than having to plug it in one by one. So that's kind of our goal here. And this is going to show you how to do it. So you're going to have this data, and these are the overall things that you need to do. And then it's going to go through on this paper step by step. And then ultimately, you're going to end up with a graph that looks like this. Okay. So this is kind of the overview page. And then as you go to the next page, it's going to show you how to do things. So once you have your file open, you are going to, we had these first 4 columns. You're going to start typing in these other columns. So on Excel, it already has E, F, G, and H. And on Numbers, those columns don't exist. And you'll see a little kind of sideways equal sign in the corner. You can click on that to add things. So you're going to give titles to what you're doing, and then you're going to put in the equation. Now, something to know about the equations is that when you type an equation, you have to do the equal sign. So if I just start typing parentheses A2 minus 32, blah, 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 it's just going to write that. It's not going to calculate anything. So you have to put equals. If I don't put the equal, then what I'm going to find is that whatever I type here, I'll do the partial equation, it just stays as what I typed. And so I want to make sure that that actually does a calculation for me. So I have to put equal. And whenever you want to multiply, so we've got multiply, let me skip that. Where is it? Okay. So here where it says multiply, in the equation, I'm using this star. So that star is above the number 8. So you do Shift 8 to do multiplication. Or if you have the number block on the side of your pad, so if you have like a PC where you have the number keypad on the side, usually there's a star there for that. And then for a fraction or for divided by, that's pretty intuitive. We're going to use that slash. And then I have here on your sheet just the minus and the parentheses. So if you look at your instructions, it says A2. Now I can type A2, but something you should know is that when you are in this box and you see the cursor up there in the box, I can just click on the cell that I want. So if you don't want to have to go through, if it's, way in the middle of your page and it's hard to figure out which number it is, you can just click on the cell and it'll go to the right one. Right, once I hit enter, you'll see I have the result of that -10. So if it was 14 degrees outside, it would be -10 degrees Celsius. It's actually a little cooler than that around here right now. So now I have this number here, and I want to do the same thing over and over again. So I could type all of that over and over again, but there's a shortcut. So there's a little box here in the corner what I want to do is grab that. So when I take my white plus and hover it over that box, it turns black. And I just drag it down and it does that same calculation for everything in this column. It does the same thing. So if I click down here on the 20 and then look up at the thing, it says A7 instead of A2. So it's doing the calculation correctly. All right. So if you're like me, you might look at this and you don't like the way that this looks like we've got cage in here somewhere. Everything's overlapping. So purely for aesthetics, just for the way it looks, this is something you can do to adjust it. You don't have to if you don't want to, but this can be something for those of us that are a little bit OCD. If I right click on this box, I have some options down here and I can go to where it says format cells. I click on that. I have some different things at the top, and so you can do different things. So if it were a number, we're going to make some adjustments later for that. But right now, this is words, and I want to wrap the text. All right. And so I'm going to click OK. And so now everything appears in there. I can also make that bold so that it kind of matches this over here. If I wanted this to have the lines around it the way the other one does, I can highlight that whole area and I can, again, format the cells. So I can go over here to format. If I'm not sure which one I want, again, just go to the bottom one, format cells, and I want a border. And so I'm going to put an outline and fill in all the lines in the middle. And ta-da, I have a border. All right, so our next one is we're going to do an average. Now, this is going to work a little bit differently, but again, we need that equal sign. We know how to do an average. We add up the numbers and then divide by how many is there. But the nice thing about the way Excel does it is if you're missing a data point or if different rows have different numbers of data, it will go ahead and account for that. So you don't have to tell it what to divide by. So I'm going to start writing average, and you'll see it pops up here. And it puts the parentheses for me. And again, I can click on here. Now notice that it tells me number, comma, numbers. So if I was typing them in, I'd do commas in between. But instead, I'm going to click on my first trial pressure and drag across. So I want the average of the 3 trials. And I want to close my parentheses. And that's my average. So you can see in the data, it's all right about 26, and my average is 26. All right, so we're going to do the same thing with our standard deviation. Make sure you have the equals. And then as I start typing standard deviation, we see stdiv. And there's some various ways to do standard deviation. We're just going to do the most basic stdev. And again, we highlight that same data. We want to see how different those numbers are from one another. Now, if we remember back to our significant figures, we know that we do not have nearly this number of significant figures. We'll talk in future weeks about how to calculate the standard deviation. That formula is in your book, but we're not going to worry about it today. But it turns out because of the way that you do the formula, we're going to end up with about 2 significant figures or information out to that first decimal place. So there are 2 ways that you can change this. Dr. Hughes gives you one way on the paper. So if looking at the paper and doing it helps you, that's the way you can do it. For me, what's easiest is that if I look at these under the word general, which means the kind of number I have, there are some symbols. So I could turn this into money if I wanted. So that tells me how much money that is, but this isn't money. So I'm going to undo that. Oops. I could make them percents. But these last 2 add or remove decimal places. So I want fewer decimal places. So I'm just going to keep clicking on that until I have just one number after the decimal point. All right, so that's how we set up our table. Now, if we want to do a chart or a graph, there are a couple ways to do this. You can highlight your data first. All right, so you highlight your data and you go to Insert. Now you can click on it. Oops. can click on insert and get the menu, or we can go over here and see there are a whole bunch of different things. This one with the dots on it is our scatter. So we're going to click on that, and there is our little graph. Now, what I want you to do is at this point, I want you to take this and move it elsewhere. Now, you can do all of the things that you need to do here and then move it, but before you finish, what I want you to do is to take this chart and move it elsewhere. The way you do that is you're going to right click on your chart at any point, whether it's finished or not, you can right click on it. And then when you right click on it, you'll see move chart to a new sheet. And so we are going to call this new sheet, whatever you want. I'm going to call it tire pressure. All right, so now it pops up here. And I can do all my editing here. And the only thing I'm seeing is this chart. So when you print it out, that means you get a nice big graph with only this on it. And that's what I prefer when you're going to print it out. If you prefer to be able to see the data while you're working on it, that's okay. You can make all your changes while you're still within the page of the data, and then move it at the end. From here, if you look at the right-hand side, it says add chart element. And we have all the things that we can do. So we already have the axes on, those are checked, but we can put titles on. So primary horizontal, primary vertical, those are labeled, and then we're going to have to change the names within there. All right, if you have gotten your graph to look something like this, make sure that your axes are labeled both with what you're measuring. So here it's tire pressure and the units, PSI, pounds per square inch. Now, I've noticed that at the bottom here, sometimes the bottom one just gets out of sight, out of mind. I'm going to make sure I record this. Oops. So I highlight it. We would use a legend if we were representing different data at the same time. So if I had data for a bicycle tire and a data for a semi tire and a data for a convertible tire, and I wanted to show them all on here, I could have different lines of different colors or different shapes. But since I only have the one, I don't need that. And then I also have my trend line here. Now, when you're choosing the trend line, you have some options here, and we're going to want linear, but we're also going to do some other things. So if you click more options, over on the right-hand side, you are going to see some of the options that you can do. This is what the line looks like. So I can make it a thicker line by increasing this. I can make it a solid line. Oops. By changing that. Those are things that I'm not too worried about. Okay, so you can just leave that the way it is, or if you want to play around with it, that's fine. What we're concerned with for this assignment is if you click on these bars over here, we're going to have some options. Okay, so as I said in the introduction, we have some different ways we can graph things, but this is linear, so we're going to leave it there. But we want to see what the equation is. So if we look down at the bottom, we have display the equation on the chart. You'll see it pop up here. And then click on those bars. And I also want to see R squared. So we see R squared is 0.989. So that's really good. But we can tell it's not an exact fit. We've got a data point that's a little bit off here, data point that's a little bit off there. So that's why it's not a perfect one. So we have the ability to forecast. So that's going to extend the dots out. We have the ability to set the intercept. So if I know it goes through the origin, I might set the intercept at 0, but in this case, it does not, so I'm not going to do that. One of the things about putting the equation on the graph is it often very, very small. So one of the things that you might want to do is highlight that, go to the home page, and then change that font to a larger size. So it doesn't have to be huge, but something that's a little bit easier to see. All right, now your directions also tell you you want to maximize your data to ink ratio. So what we want to do is we want to focus in on this data. And so we're actually going to truncate on purpose because really having a tire pressure down this low means you have a flat. So what we're going to be looking at is just this area here. And so if we click on the numbers for the axis, it's going to highlight all of those. Okay, and we can see over on the side, it says axis options. And so we have some things we can do over here. And we can click around to see some of the different things that it will allow us to do. But if you click on the bars where it says axis options, you will see minimum and maximum. Now, if you didn't have that pop up, the other thing you can do is while you're here, you can, oops, on that, and then right click. So right click is what made this box pop up, and click on Format Axis, and then we should see those. So we can see our lowest data point is above the 25. So 25 might be a good place to have our minimum. And when I put that in, oops, it changes my graph. All the data is still visible, but I've spread it out so I get a better sense of where that data falls. And I can see a little bit more this change here where these data points are a little bit below that line. So that is how you change the size or change the data range in order to have better data to ink ratio. Okay, in order to specify or in order to put in the error bars, what you can do is, well, first of all, if you've been moving around and you don't see these elements here, when you are on your chart, look for where it says chart design, and then we should see these things pop up once more. So we can add our chart elements here. So one way to add the error bars is if we click on here, we can add error bars and go to more error bar options. And it's going to automatically put on the vertical and horizontal, and it's just going to give it a standard amount. So we want just the vertical ones. And so if I, oops, click on just to the side there where it has the horizontal. So now over here on the right-hand side, it says horizontal error bars. I really don't want to have these at all. Okay, so what I'm going to do is while all of those are highlighted, I'm just going to hit delete, and it's going to delete all of those. Now, right now it's showing the same size of error for each of these, and that's not really what I want to see. So I'm going to click on the vertical error bar again. I want it to show the deviation from our data. So I'm going to go down to the bottom where it says custom. I'm going to click on custom and specify value, and it's going to pop up here. Now, when it has this thing in the corner, this little box in the corner, that means I can click on it and it's going to go to my data. So I'm going to click there, and I'm going to go back to the scatter plot, and I'm going to select all of this column. And so what it's going to do is for the first data point, assign the 1.2, and for the second data point, the 0.5, so on and so forth. Now this says positive value. So it's going to make the line go up, but I also want it to go down. And so the negative error value, again, I'm going to click on that same box, highlight the same data. And then if I click on the box again, it's going to give me this and show me what I've just selected. And I'm going to click OK. And now we go back to the graph, and you can see for some of the data points, this error line is very small here and here. And then for some of the data points, it's much larger. And so that's based on whatever the standard deviation value is.
Professor Knapp.
Yes.
And to create the bar graph, do we need to follow the same instructions as the scatter plot?
Correct. So if I I don't have the calculations done, but if I wanted to do a bar graph of the data, you're seeing the bar graph data here, right?
Yeah.
Um, you can do the insert chart and then choose bar graph in here. But you're going to want to change it to a vertical bar graph instead of a horizontal bar graph. So let's see, if I just click on insert, it can also go to this, and then it gives me the different options. So I'm going to have it be vertical like that. And again, I would take this um, and then right click, move the chart, and put it in the different window. And that way
Okay.
it's a big screen.
All right.
But otherwise, yes, it's pretty similar.
All right. Thank you.
You're welcome.
Thing.
So let me find the data again, part B. Yeah, if I've got this highlighted and I look at the types, it looks like 3 lines here. It looks like multiple lines, but when I choose it, it's gonna only show 1 line. But remember, you have to, I kind of skipped over the math part that we did at the beginning. You're gonna have to go through and make a column for the averages and a column for, I forget what all it asks for. Do that first. And so you're not going to be highlighting these, the original data, you're going to be highlighting the average. Okay. It doesn't specify that, but in order to get the error bars, you need to have an average and then the set. So yes, it wants you to do just like you did in the other one. You're going to create a column that is the average and a column that is the standard deviation.
On the instructions, it says to use color to showcase the results of the experiment. So does it want like the largest one to be a different color?
So, I'm not going to grade on that. I think kind of what Dr. Hughes had in mind was how it said, okay, well, we could show by how intense it is. So I can maybe say, I want this very tall one to be dark blue, but this shorter one, maybe I want that to be lighter blue. So the way I would do that is right now, this is the only one that is highlighted. I'd go to the little paint thing and oh gosh, I have to choose. Oh, that's the border. I want the fill. Instead of the dark blue, maybe I'll choose light blue for that one
Okay.
and then just change it for each of those. I'm not going to look at that. That would be more appropriate if I had these in order. So maybe I had C first and then A, B, and D.
Right. Right. I
But
see.
it's something you can do.
But we don't have to for this specific
Yeah.
assignment. Okay. And then I have one more question. You want the on the paper it says on the I think it's vertical axis, it says reaction rate and then like moles, blah blah blah. And then on the top it has the title. You want both of those too, right?
Yes. Now
Okay.
where it has the mole dot leader to the -1, S to the -1,
Yeah.
it is really hard on Excel to format things so that they're superscript and subscript. So what I would do is, let me see if I can show you, chart design. I am going to add my vertical axis. What I would do is I would say rate, and then I'm going to put molarity. So that's moles per liter. So that takes
Yeah.
care of the mole times L to the -1, and then slash seconds. So I
Okay.
know that's really small, but can you see what I did there?
Yeah, yeah, I got it. Thank you.